Welcome. We are back, this time with climate science. It's part 2 of the 4-part series with Equality Bahamas in conversation with the great Marjan Finlayson, who is teaching us all the things. And today it's a big topic. It's one that it's kind of hard to say we like this topic, but we circle it often. And there's a certain time of year that we really get riled up about it. And we're right in that time of year right now. It is hurricane season. So we're going to talk about it. We can talk about hurricanes.
A favorite topic of mine, personally.
I mean, I guess it's okay for it to be your favorite. Like somebody has to be into it and tell us what's going on. The rest of us are just like, please, please, please. No, don't come here.
Prayer warriors up. Yes.
We don't want you here. We don't want you there. We actually don't want you anywhere, you know?
Definitely.
So what are you thinking we're going to get into today? I mean, you never know what questions I'm going to ask, but what do you think is going to happen?
I think we'll talk a little bit more about, how hurricanes form. What's the big fear? Is climate change going to affect them? Should we be more concerned? All that good stuff, which of course we're going to talk about. But before we get into all that, of course, I want to talk about the goal of the session and then go into everything else. Yes?
Sounds good.
Okay. Yes, as Alicia mentioned, this is part 2 of a 4-part series, so we'll be back again in 2 weeks to talk about some more climate change stuff. And the goal of these sessions is ultimately to spotlight ways to help people in need. I know a lot of us want to help people in dire situations, but we never know when to start. So with this information on climate change, we hope to provide information and resources that will be helpful for people in need. That includes making donations on our GoFundMe page, on the FinForecast blog. If you are a FinForecast subscriber, this is an opportunity to subscribe as well. And the link for that is tinyurl.com/SUNDON, Sundon. And our spotlights today will be local GFMs for Ariel Usher, who is in hospital and need to pay hospital bills, and international focus on Focus Congo, where you can donate money, materials, and download their prayer guide to pray for them if you so desire to. So those are people who we're spotlighting today, and you can go onto the website and check it out. The link will be in my Instagram and all over the place.
Yeah, again, tinyurl.com/SUNDON. And sometimes these things are a little bit case funky. So if that doesn't work when you put in small letters, try tinyurl.com/S, small UN, capital DON. And again, we're going to put it in the comments wherever this recording gets posted. So I guess we're going to get right into it. We did a little intro, but we didn't tell anybody who we are, which I'm famous for. I'm really well known for going through a 2-hour session and being like, by the way, I'm Alicia. So I'm Alicia from Equality Bahamas. We promote women's and LGBTQI plus people's rights as human rights. And we entered the climate justice space officially around the time of Hurricane Dorian in September 2019, when we kind of got thrust into hurricane relief and wanting to go beyond that and focus on addressing this issue at the core and bringing some attention to the ways that the Bahamas, Caribbean countries, small island developing states are disproportionately impacted by climate change and climate catastrophe. Who are you, Marjan?
Thank you for asking. I am a climate change scientist and expert, educator, and I'd say slacktivist, not really activist, but working on a PhD right now in the University of Bologna, having a great time doing that, focused on oceanography. And when I say I'm a climate change scientist, climate change expert, I focus mostly on the science part of it because it's such a broad thing to say. Like climate change could cover policy, social, all types of things. So I'm more of a science person, and I've been obsessed with hurricanes since I was a little girl. So that's what kind of got me into this spot, actually.
Cool. So again, we're talking about hurricanes. As I said last week, as I say every time doing something like this, I think it's important that we get the definitions out there. So we feel like we know hurricanes, right? We experience them. We've all grown up kind of watching our parents and participating in household preparation for hurricanes. But what are they really in more scientific terms, but scientific terms that we can understand?
Okay, a hurricane is actually what we call a tropical cyclone. It's the worst part of that thing. So you have a tropical depression that we name in the North Atlantic region. We call them tropical cyclones. In the Western Pacific, which would be where the Philippines is, and I mentioned the Philippines because they get hit a lot, they get referred to as typhoons, right? And in other places in the world, they hit in different regions, but we see them a lot in North America because a lot of countries are in that basin. Also in the Eastern Pacific, right? Eastern Pacific, yes, Eastern Pacific, which would be your Californias, and then Western Pacific, they see a lot of typhoons and things like that. And all of those storms are categorized as tropical cyclones. Essentially, we would look at from the Saffir-Simpson scale, when we started having a tropical depression, which would be the lowest form of a hurricane, like right before you get to a hurricane, you have a tropical storm, and you have a hurricane categories 1, 2, 3, 4, and 5. All of those, all 7 categories would be described as tropical cyclones. So when you hear about people on the news talking about tropical cyclone development, we're talking about the system developing itself. A tropical cyclone would be like a low pressure system. So when we talk about low pressure systems on like an atmospheric front or like weather, you're talking about systems that are taking in a lot of pressure, really, and causing like cyclonic movement. Cyclonic, anti-cyclonic? Yeah, I think it's cyclonic movement, which actually causes more convective activity, which would be thunderstorms to form in that region. So what happens is the low pressure system is taking in more pressure, and a lot of times a cluster of thunderstorms, which would in some cases, a lot of cases with hurricanes that happen in the North Atlantic, come off the coast of East Africa. So a lot of these storms kind of come together and cluster and basically start moving in a cyclone, like cyclonic movement. That's why you have a tropical cyclone, right? And as it goes over the sea, it strengthens because the sea surface temperature, right, the hot water from the sea surface actually makes the convection stronger. So you have stronger storms that occur with this evaporation that's happening from the sea surface. And as a result of that, you get stronger winds, which is what we use to measure how intense a hurricane is. So with that, there's also the actual humidity that happens higher up in the atmosphere. So, we have the troposphere, which is like the closest layer of the atmosphere on Earth. In the middle of that, where if there's a lot of humidity, that can also add to the strength of the hurricane itself. One of the things that we also know that can actually inhibit hurricane strength is vertical wind shear. And that's the difference between wind shear at the very top of the atmosphere and wind shear at the very bottom. So if it's very weak, then you have storms that it's like less resistance, basically. Like think of a wall of wind that could cause resistance for the storms to actually form. And if it's really weak, and there's less resistance, the storms can strengthen again. But if it's really strong, it could deplete the storm. So that's important to think about with development. One of the things that we're also looking into is originally sea surface temperature was the key to look into. Now it's ocean, well, not now, but ocean heat content is something that's also really important. And ocean heat content is really looking at the heat capacity. That's how long heat can be stored in the depths of the ocean layers, right? So with the sea surface, you're really just looking at the top layer, which could be like down to 10 meters. But if you go down to the ocean heat content, you're looking down to like 700 meters of the ocean. How hot is that? Or like down to 2000, how hot is that? And if that heat actually cycles and affects the storm strength, like the storm strengthening as well. So, there are other factors to also, to keep in mind, but that's the main thing to like get an idea of a hurricane. So what I like to tell students is that a hurricane needs a couple of things, like a recipe to build it. You need thunderstorms, so convection, which would be like your low pressure system, and you need a lot of hot water. You need some humidity in the atmosphere, and you need a very little resistance that comes from the vertical wind shear for you to get hurricanes to develop. Yes, and I will stop there for now.
I can tell you're very into this. That's very, very cool. That was very interesting to think about. And I was waiting for you to get to the ocean heat part, because I know that it seems like we're treating that as a predictor of hurricanes or frequency or what the season is going to be like. Can you talk a little bit about, how we predict hurricanes and how people make these kinds of projections about what the season is going to be like? Because when I start to see these projections, I don't know when does it happen, like May or June, I'm kind of like, how are they doing this? How do they know?
Yeah. Hurricane projections is a fun thing to do. Well, not really. Well, it's fun in like a painful sense, only because it involves a lot of computer modeling. And so what happens is at some point before the season starts, you have like these big institutions like NOAA or the ECMWF, which would be the European modelers, and then like the Japanese Meteorological Agency and like other places that could predict hurricane intensity by the season. And they would take the different factors that I mentioned, right? So within the model itself, there are like different equations that are used to get a kind of spaghetti model. And this happens through numerical weather predictions processes. So that could be long-term, which I like to look into, versus like a very short-term prediction. And so what basically happens is with these equations that are put into the system, and it's a very complex thing that I am constantly learning about all the time. What happens is you put in different factors that could affect hurricane development based on what they're seeing, based on observations, right? So basically, what would happen is if you're taking, like, consider a buoy out at sea, right? The buoy takes sea surface temperatures all the time, consistently, depending on where the buoy comes from with different sources of information. So NOAA actually has a lot of buoys. It has Argo floats in the ocean that takes like consistent salinity, temperature, chlorophyll, dissolved oxygen information from the ocean, as well as gliders that they've been using at the Cape Eleuthera Institute, in Eleuthera now, and gliders all throughout the North Atlantic region. There are, I think, other buoys all around, sail drones I know they've put out, and like different agencies have different tools that they put out, and that information is shared amongst agencies, and whatever, and of course, satellite data, can't forget that. Satellite data is also used. And those satellite data takes all this different information from the ocean and also information of the atmosphere above the ocean to get an idea of like what's changing and the different variables they need to look into, which would be sea surface temperature, humidity in the troposphere, salinity at the ocean, temperature, all types of things. And they basically input that information. All that the observational data is input into the system. At the same time, data from other hurricane seasons would also be compared, right? So like whatever observational data was taken from like say 2023 and refined in a different way with other mathematical equations, that's compared with the observational data, and together they're able to bring that together in a way. So you can imagine like A is real time observations, B is like last year's observations, which are kind of seen as a truth. You compare the two of those things, bring them together so we could bring like C, a prediction based on these observations of what could happen. So get an idea, because we can't predict, like if we have the observational data from like May 2024, we wouldn't have the observational data of September 2024 to give an idea of what would happen. But if we have the observational data of 2023, 2022, 2021, we can get a kind of an idea of what could happen in 2024 based on the data that we have. And then with that, they also have to keep in account other variables that could be happening, like the El Nino, the La Nina, and other climatel connections that could actually affect the long-term development of the hurricanes. So it's a very, and they do all this to make really pretty line plots to get an idea of like how many storms might hit a season, what's the possible amount of storms that could happen in this month, what's the possible that could happen in this month. So they do all that work to get you and make these very pretty plots. When you're talking about predicting storms like 5 days in and out, it would be looking at observational data and trying to figure out based on what the observational data is doing, what's happening. So observing satellites, observing the actual conditions of the area, and then also watching to see clusters of storms. For a lot of places, they have like, I didn't want to be a hurricane chaser, but kind of, like people who would go into the helicopters, the Navy helicopters. You can't just go into a helicopter. Like, I know there are billionaires who would, but don't do that. You have to have like an Army grade like helicopter that you go into to actually measure the storm for observational data. So when there's an actual tropical storm forming, you have actual people in like different, I think American, I'm not sure, European, I think European too, UK, they actually go and check on the storms and physically will like do the tests and stuff like that within the helicopter itself to give you an idea of like what's happening in real time. So all that data that you see that comes up like when a storm, like if you go on the NOAA National Hurricane Center website, there's always like a write-up of what's going on with the storm, and that could come from a forecasting center, and that data from the forecasting center is coming from like people who are like chasing the storm and like watching like what it's doing in real time.
The predictions for this year were a little scary.
Yes.
And
yes,
I don't want to follow that up with anything because I believe in like the power of our words. I did see an article in the Tribune this week that's saying that the Sahara dust is our reason for what we are experiencing now, which is not quite what was predicted.
mm-hmm.
How does that work?
So the Sahara dust, also known as like the Sahara air layer, is something that goes into, I have like a friend who's really, really into dust as a climate scientist. So like whenever I talk about it, I always think about her getting
really into dust.
Really into dust. Yeah, like the
so
long the long transport of dust and how it affects climate. I'm like, you can find this topic for anything. So I think about her whenever I talk about it, but the Saharan air layer, basically, it inhibits, again, like tropical cyclone formation because it kind of transports, like, if you can imagine, like specks of like aerosols, right, that are moving all about the place. So if there's moisture that attaches to those aerosols, it kind of like stops like storm formation in general. So it causes an issue for formation, and it also emits a lot of high pressure that comes with that when it like is traveling across the land. And high pressure and low pressure don't really go together. I don't know, like they don't really match. So it inhibits convection, it inhibits like pressures from lowering. So it's harder for storms to actually form. It's not impossible, but it is harder. Now, would I say that the Saharan air layer is the reason you're seeing less storms right now? No, but I would, there's like a strange quiet period that is happening. That is something that's being looked at the university. I know the Colorado State University put out a informational packet, I think a week, maybe 2 weeks ago, talking about this strange quiet period. But I wouldn't say it's because of the Saharan air layer. I'd say it's maybe that may have some effect. It's like based on what I was seeing last week, not really. Because you're still seeing a lot of storms happening right now in the Bahamas, right? Like a lot of raining and a lot of stuff like that. If it was the Saharan air layer like causing a lot of issue there, you would see more sunny skies. So over the Bahamas in general, but if you're looking at the main development region and all these other places, consider the Bahamas, right? So shout out to Wayne Neely, the ultimate hurricane chaser in the Bahamas. He has at least like maybe 4 or 3 books just about hurricanes in the Bahamas in the North Atlantic region. It's very impressive. But it was him who pointed out this phenomenon that in the Bahamas, like we're affected by 4 types of hurricanes in the idea that hurricanes form in 4 different regions. One being the main development region, which is basically the North Atlantic between 10 degrees north and 20 degrees north, and like in the middle of the Atlantic Ocean. And that's where the strongest storms normally come from. So we're affected by those. Everybody's affected by those. There are also storms that form in the Gulf of Mexico that you might see right now. If you look at the National Hurricane Center, you might see a storm developing there. Those normally affect like parts of like Latin America, some parts of the Caribbean, but definitely the Bahamas and Florida. There are storms that form in the Caribbean Sea that can also affect us, so they just move up. And then there are storms that form just in the north, like east of the Bahamas, kind of, that Wayne Neely calls Bahama Busters, that can affect us. So we're affected by storms formed all over the place. So when there's like an idea that the Saharan air layer could cause issue with that, I would argue that in this certain moment, this certain time, you would see more storm development based on like how convection is working right now. So I wouldn't say it would be the Saharan, like maybe that could be part of the impact, but I would say there may be something with, I'm not sure what I would say. I wouldn't say the air layer though. I would say it may be something to do with temperature, maybe salinity, maybe something changing in terms of like humidity structure. I'm not sure, but I wouldn't. Maybe vertical wind shear is something that is a really like a key thing. But yes.
Okay, we gotta shout out the climate conscious who's watching on Instagram. Follow the climate conscious, y'all. Hi, y'all. Thanks for watching. So what else can affect the season and how active or inactive it is?
Let me think about that. What else can affect the season?
The hurricane, for those who just joining.
So there's this phenomenon, kind of. It's not really a phenomenon. It's something I think like recently a lot of people are focusing on. So hurricane studies is relatively new in the sense that like people who've been like studying the science of it, all of the people who are like the founders are all still alive. Well, not really. Well, except for William Gray. Most of them are alive. So you could like literally reach out and be like, oh my gosh, hey, do you know this? So there was originally a lot of focus on the atmospheric components of like how hurricanes will affect and like form, basically because modeling was easy with just the atmosphere versus like with the ocean models as well. And now there's more focus on the ocean parts of things, just not just the sea surface temperature. So like I mentioned before, the ocean heat content is something that's being looked at more frequently now, and also salinity. So sea surface salinity is kind of weird because it, depending on how salty the ocean is, it could actually block evaporation. So if it's like super salty, it could block evaporation. But if there's less salt in the ocean, it could cause like more evaporation happening. So the fresher the water is, the more you'd see like more hurricane strengthening or developing. That's a thing that we keep in mind. So the ocean is different from the atmosphere in that the ocean water masses move more slowly than air masses. So if you have a particular mass of ocean that comes from like a river in like Venezuela, I can't honor the Orinoco River. I'm wrong. My geography is off. But if you have some fresher water that comes from the ocean that might be traveling through like different areas and like flows up to say the Caribbean and like the water's a little fresher, it makes it easier for a hurricane to strengthen because fresher water is meeting saltier water. But if the water is saltier, then it's harder for the hurricane to strengthen. So that's something to also keep in mind. Now, it's something that needs a little bit more study to watch and like look into, but it is something to keep in mind in terms of like ocean stuff. And that's why it's really important to do ocean observations, which are really hard to do. It's really easier to do atmospheric observations because of satellite data and all this other stuff that you can do with that. But ocean observations are really hard because the ocean is very big and we are very small.
Thankfully, the ocean is like so big.
It's so big. Like, think about the Pacific Ocean alone. It's so big.
So when we think about salinity and what you're talking about with like the fresh water coming in at certain points, does that determine the formation of a hurricane, or does it affect the movement and the lifespan of a hurricane?
I would say it would definitely mess with the development, and it probably could affect track, like the movement. But in terms of formation, I would not say that would be a starting point for tropical like hurricane genesis. Maybe because it's easier for the storms, like basic storms, to form, and you need a bunch of storms to make a hurricane. Another thing to consider with our region in particular is because the earth is always moving, right? The earth is always spinning. And with the earth spinning, there's actually a convergence zone, the intertropical convergence zone, which is an area that's supposed to be right above the equator, but it's not because it's always moving up and down. And it's where you have a lot of rain. That's where the convergence happens. So it's a lot of rain happening, and that affects like rainforests and like different areas in like South America, Central America, and places like that. If that moves, it shifts a little northward, that can affect hurricane development because it's giving more precipitation, more evaporation, more action happening. If it's shifting a little lower, it could affect like whether or not you have more storm genesis in that region. But it's interesting that you mentioned like storm movement, because that's a weird one too. Because how do you know where a storm will go? You have the models. They give you an idea of like, okay, with the bunch of hurricane tracks, like the different spaghetti model, it gives you an idea of like where a storm possibly could go. And then it also can tell you how strong that storm could develop based on where it goes. But most of the time, that's why you see a cone, because no one's really sure where that's going to happen. Because we have this, there's a saying that no matter what you do with modeling, whether it's weather, climate, hurricanes, the model's always wrong. You have to always apply like knowledge of like how things are with observations to get an idea of what that is. So with the hurricane movement, it could be affected by a number of things. One of the things that there was a paper that mentioned this years ago, I'm not really sure if it's still relevant, but literally like a El Nino or a La Nina could affect, like whether or not you have an El Nino one year or a La Nina the other year, that could affect where a storm might go. Where a storm, like with a La Nina, it might hit land. With the El Nino, it is more likely not to. That's one of the things. There's also like talks of like how the Atlantic La Nina and El Nino could make a difference, and like all types of other things that can make an effect on that. Of course, when we talk about ocean heat content, there's a likelihood that we expect more tracks to move in that area. But it's easier to think in terms of like where there are more favorable conditions for storm development is more likely where a storm would want to go. So it's easier to think of like, where would a storm want to go? If the water is really hot in a sea surface temperature, a storm would want to go in that area. If the water is cooler, a storm would not want to go in that area, so they might shift to the warmer areas. If the water is less salty, it might want to move there. So that's a way to think about it in terms of when you're looking at a cone. A cone that gives you an idea of where the predictions are, where the storm's predicted to go. It could be right here or somewhere in the middle. But if it's moving in that direction, if you have an idea of like the observational data of the area, it could give you an idea of where the storm may possibly be. But again, there's a lot of uncertainty that comes with that. And that's a magic word that I've learned throughout my journey in this field. Uncertainty is the big word.
Uncertainty. It's also a very unfriendly word. We don't like that at all. So when we hear that something's coming, I can't remember, it's not usually not a hurricane at first, right? It's a
tropical storm.
And then there are these increases. Can you talk us through what is changing to prompt the change in categorization?
Yes. So I'll tell you a story. It was really funny. So when I first did like my master's degree, right, I went up to this like office of this lady who's like into storms, right? And I was really excited. She became my supervisor later, and thank God, because I think she thought I was a little crazy. That's fine. I walked into the office and I basically was like, hey girl, let's talk about Category 6 storms. Hurricane Dorian just happened, and I was like, girl, that was not right. I've been through hurricanes my whole life. Let's talk about Category 6s. Let's take it up. And I thought I was going to be that person to make that discovery, right? And she was like, girl, I understand your life story, right? But like, relax. Chill with that. Because like at that time, right, I was like, okay, hurricanes, climate change, it's all going down. It's happening. It's going to be a mess. I know it in my heart that we gotta take it up. And she was like, again, relax. You just arrived. You don't know what you're talking about. And she was right. So the thing is with the way we categorize storms, especially in the North Atlantic, like keep in mind, we categorize by the Saffir-Simpson scale. And that goes from tropical depressions, tropical storms, category 1s, 2, 3, 4, 5 being the most deadly. And the way we measure is by wind speed and how damaging that can be, because that's really the only thing you can measure when it comes to storms. You can't really measure how much rainfall there's going to be. You can't really measure like how cloudy it may be, how much cloud cover. You can't really measure those things, but you can measure. And like to an extent, you can measure storm surge, but like, not really. Because again, sea level is hard to measure as well. Because remember, the ocean is really big. So when it comes down to it, the winds is how we measure these storms. So the intensity of winds is the thing that we're looking at. The issue now, though, isn't just that the winds may be more like we expect to see in the future, which is kind of now, but also more, that you kind of expect to see more major category storms, which would be the 3s, the 4s, and the 5s versus the 1s and 2s, because of like how easy it is for storms to form compared to the past. However, there's also another issue with precipitation. So rain is actually becoming a little more intense than we were used to with hurricanes. And that's because there's more evaporation happening with climate change. And there's also some studies that are showing that storms themselves are slowing down more than they used to before, which makes it hard. Like, so if you can imagine, right? If a storm is traveling at a 20 miles per hour pace, it's going, it leaves some rain and it goes. Now, if the storms are going slower, if it's raining at the rate it was, let's say back in, if I said my storm happened in 1999, 2024, if the storm is traveling at a slower pace with the same amount of rain, you're going to get more rain in that spot because the storm is moving more slowly, right? So that increases the rain rate in the region. But we're expecting to see more rain with more evaporation, more convection, because hotter sea surfaces, hotter ocean temperatures, fresher waters because of the ice caps melting. Remember the glaciers? So we're expecting to see more precipitation. More precipitation, slower storms, hurricanes means more flooding. And then on top of that, you have sea level rise. That's definitely happening. We talked about sea level rise last time. More sea level rise happening, which means the storm surge, which is basically the water that's coming from the actual ocean or like different parts that are affected by the storm that's coming inland. You're going to see more water. So you have more water that could be flooding from the sky and more water that's flooding from the ocean that's coming in to make those effects even stronger. So though we only can measure by the wind speed themselves, and we can't really go up to Hurricane 6, and I really thought I was going to make that up. We can't really go up to the Category 6 hurricane. We know that we should expect to see more rainfall no matter what the storm is, and more storm surge no matter what the storm is. So even when you're looking at like a tropical depression or a tropical storm, we expect to see more rainfall. So now one of the key messages is that people are putting out, right, is that, okay, it's a tropical storm, the wind isn't that much, but the rain's still probably going to be very heavy. So you should be prepared regardless, because it's going to be flooding. It's going to be intense rains. Your gardens are probably going to be underwater at some point. So you need to prepare for that. I know a lot of people talk about like sandbag effects and things like that. I can't really speak to disaster management. But you know who does? The DRA management? Was it the DRM authority?
DRM.
Okay, yeah. I just saw that video and I was like, oh, it was so fun. Not fun, but good, very good. But they No, but they're very good. So they have more information on how to prepare for the disasters, which I think is awesome. But in terms of that, like rain, be concerned about the rain. That's definitely what I would say in terms of like the changing of categorization. We can't really switch because we don't know what other thing to measure hurricanes by, but we know that there's going to be more rain. We know that storms probably are moving slower. The winds, of course, remain the same, like intensity, and then more hurricanes that are going to be 3, 4s, and 5s, and storm surge is going to go up. And of course, with all of that, when you consider the rain, soil's not going to absorb rain the same way, so you expect flooding in all areas. That's why you see more rain now happening in different regions just from regular storms. If it's raining too much, when the soil and the ground becomes super saturated, it's harder for it to absorb the rain, so it's going to lead to flooding. At the same time, when you have more heat waves, like we saw with the wildfires that happened earlier this year, when the slight heat wave, when the ground is drier, it's harder for it to absorb rain too. So that leads to more flooding again. So there are different things, like the extreme weather can lead to more flooding just in general. So that's something that a lot of us have to really sit with. I apologize to folks in Pinewood. things are already tough. But it's like a realistic situation to really think about going forward in terms of like, it's not the wind is bad, but the rain is something to really, really think about and be concerned about.
What to give people a little more context and to kind of separate out the rain fall from the storm surge. Can you speak to Hurricane Dorian and what happened there?
I will do my very best to conceptualize it. So like for Hurricane Dorian, the storm, again, it stalled, right? So we remember like Hurricane Dorian stalled over the northern Bahamas and it was like stuck there for a while. And I think it was moving at like 5 miles per hour at some point. Like it slowed down as it got over Grand Bahama and Abaco. It like slowed down entirely and then it stopped. So when you consider this storm already was a category 5. It already had made a lot of wreckage in Puerto Rico and had like great effects in different parts of the region itself. But the rain would have, because it stopped and it was such intense rain, you saw that there was more rain falling down with the like slow movement or no movement of the storm. And that constant rain would have led to flooding in the ground and again, stopping the ground from actually absorbing water, which would cause an issue. Another thing is with the storm surge itself, again, considering when the storm is moving in, right? If you think of it kind of like they say like an engine, right? The storm has to function on heat, and so it moves in a particular way. And in its movement, it's pulling in a lot of pressure. And when it pulls in pressure, it can pull in, that's going to affect actually like not just air by force, but also like ocean by force. So a lot of the ocean stuff is going to be held back as it moves forward. As it approaches, the water recedes, right? Ocean water recedes. And as it approaches, that same water is going to come back with a higher, bigger force. And that's what causes a lot of storm surge that accompanies the storm itself. So in thinking about these two phenomena that happen to have like a similar effect, which would be flooding on these places, we consider the slow movement of the storm, but also the actual pushing of the actual ocean water into the area itself. And because the ocean, again, sea levels have increased, we expect to see more of that storm surge that happens in the future. And this is something that's happened before. Like storm surge is something that has existed before. When I say before climate change, I was like, before we saw extreme climate changes, I would say. Storm surge isn't new, but it's more intense than it had been in the past because we have higher sea levels and, expansion on the ocean with the heat that we talked about last time. And with the hurricanes, again, something to look into. With Hurricane Dorian, there was actual stalling that happened with like atmospheric components that actually made it stop in that area. But there are studies that are looking into whether or not storms are slowing down as they move over places. So will it come to a complete stop? Will another storm come to a complete stop when it's moving over a place? I couldn't say that, but there's an idea that they're actually just slowing down in general, which increases rain rates, which is just the amount of rain that falls in a particular area over a particular amount of time. The more time a storm spends over a place, the more rainfall. And increasing temperatures, increasing sea surface temperatures, increasing evaporation leads to heavier rainfall. So more time, more rain, more storm surge, all leads to more flooding. So of course, just considering the dangers of the water. And of course, you still have to deal with the high winds. So it's not even like that's it. You still have to deal with the high winds that are very intense when you have category 3s, 4s, and 5s. So that's also stuff to consider. Does that answer your question?
Yes.
Okay.
And so my next question is, we're seeing the changes in the storms themselves and the hurricanes themselves. Like I think Hurricane Dorian blew our minds in the Bahamas, yes, across the region, and all over the world, really seeing a category 5 storm that many people thought it should be a 6 like you. And that just sat there for a full day, just decided to hang out. How should our preparation change? Like, what do we need to do differently, knowing what we know now but also not knowing exactly what is coming?
What should we do differently? Well, I know last time I mentioned the life vest, and my mom literally called me out and was like, "Stop telling people my business." But I mean, that could be a step one, right? But also,
I need your mom to know that I also bought a life vest for myself and my mother, and I meant to have it right here so I could show it. Next time I'm going to show it.
See, she's not the only one. So just considering, like, of course, like that's a good way to take care of individual needs, right? But like also having like a hurricane plan. I know someone I really like, Paris Griffin, who is at the DRM Authority, always talks about having a hurricane plan together, checking buildings, making sure like things are safe. And this is stuff that could happen within families and communities, doing all of that. Knowing your local hurricane shelter is very important, and also making sure that they are like prep for the hurricanes are a big deal. Like one of the concerns I had when I was living in Eleuthera 2 years ago, for 2 years. Was it 2 years ago? Maybe it was. What my biggest concern was, like, the hurricane shelters I knew about were like, local schools. And I used to spend time in local schools because, I worked there. It was fun. But I was there all like days of the week. And I was like, I'm kind of concerned about this being a local hurricane shelter. I'm not going to lie. Doesn't look super, And of course, that could be local government, big government, but that was a huge concern. I was like, I don't really know if these hurricane shelters are like super safe. So yeah, so I think like,
and they're not, right? These are just buildings that exist. It's like, well, this is a church, this is a school. Let's just use that. Oh, that could fit 200 cots, and that's what determines what gets to be a shelter. It seems. Can't say.
I think so. No, I wouldn't know. There are people whose job it is to know, but I do think that it's important for individual communities who know, once you have a hurricane plan, if you know that your local shelter is this place and you know that your home is not good, of course we could pressure the government to do more, but it's a lot of islands in the Bahamas. I think it takes a lot of community effort to make sure those shelters are safe and stocked with local things as well, so people are aware of things to we have this, we're good. In case this happens, we all know we could come to this place. This building is not well inspected. We need this, we need this. We need to contact our local government to make sure this is done, just so that people can have a step. You don't feel helpless in this situation. You step forward into something that you can make a difference. Hopefully that would work. I think so. Another thing I would say is I think education is key. Of course, you don't want to tell people too much, do the research, because that's become the worst thing you could say to anyone these days with misinformation. But I think it's really important to understand how hurricanes work, how they develop, how the actual, so a lot of times we get information from the NOAA National Hurricane Center that sends off those images that go off with the cones and things like that people can look at. And a lot of times, people like my dad and my uncles, they are deeply invested in it now. And I think we all have an idea based on that, and based on what the weather person in Florida tells you is going to happen, it's going to happen with these wonderful images. But also keep in mind, these images are things that are sent out to give you a simpler idea of what could happen. It doesn't give you the full picture. So it's important to understand what those cones actually mean, fully understand that, fully look at the direction. And then also just keep in mind, the cones are models. They're spaghetti models, different lines going in different regions. So it gives you an idea of the amount of uncertainty we have of where the storms are going to hit. I always tell people, I look at the storms. I think there are 7-day forecasts now that you could look at. Before it was 5 days. I look at every 3 days. I don't trust the 5 days, but on day 4, something's going to change always. Hurricane prediction is very similar to weather. No matter what it is, you got to check it every day to make sure you know what's happening. So that would give you an idea of what to do and how to prepare. But what else? I don't know. I'm really on the predicting side of things and the study after side of things. But when it comes to the after effect, I'm just not that well versed, I think.
Come on now, your predictions are supposed to help us prepare.
And that's the jokey part, like the prediction, there's so much time and energy spent into predictions internationally. People can tell you the predictions, the research, the climate effects, all this stuff. When it comes to like the actual, okay, so now what do we do after it hits? Or now what do we do when it's coming?
To help?
Nothing. We don't know.
I want to think a little bit, or like challenge what you were saying earlier about people getting out there in communities, in families, checking out these buildings, and that you can't wait for the government. And that is a fact. And I have to add that we are supposed to be able to depend on the government to do this and to do it properly, right? We are not supposed to be running around the place with measuring tape and I don't know, whatever stuff you use to assess buildings. Like that just should not be our thing, especially when we got to go to work every day. We have families to take care of. And I have a real problem with the way that we talk about resilience as an individual effort instead of focusing on it as a way to build systems that are sustainable, that are effective, that are efficient, that are making the best use of our taxpayer dollars. This is not supposed to be the work of working people and families and communities. And I'm glad that you said, come together as a community to do this work together, because that is what it comes down to. When governments fail us and when we can't trust them, we do have to do it for ourselves. But we have, as Bahamians who consume a lot of North American media that is very neoliberal, very individualistic, it's really important that we don't, as my friend and fellow advocate says all the time, just solve our problems with money.
And
like I can solve my problems with money, but the problem still exists all my neighbors. Right?
Yes. And there's also like a level of it. No, go ahead. Sorry. No, there's also like a level of it where it's like, well, just let's make it just go away. Like, we know it's going to happen, but like, just, and like, I feel bad about it kind of because I'm like, oh, but my field is kind of like, okay, this is going to happen. And I'm so excited to talk about like all the early warning systems they're doing at the World Meteorological Organization that's going to help us in the future. And like, they're doing all this exciting, cool stuff with AI and well, AI, but like AI and all this cool stuff is going to be great. And we're going to be able to predict it. But then you go on the ground and you're like, and that's it. I don't really know what to do to help y'all outside that.
And what does that mean for people and their lives?
Exactly. So like, and it's interesting, like going back to when I lived in Duluth or whenever that time period was, I swear, 2 years ago, 1 year ago, who's sure. But when I was there, one of those time periods. At this point, time is an illusion. So anyways, I was there and a lot of responsibility fell on the organization I worked for to actually like do like stuff to prepare for this stuff. And there was like a handbook and like a guide. And I swear to God, every day I was scared because they would be like, all right, MJ, what's the prediction? I used to be like, y'all lives are in my hands. Oh no. I was scared every day. Like every day of the hurricane season, I was like, Lord, please don't let this be the day. But when it came down to it, it was like this organization had more responsibility. And I think that there was a conversation. Now, I can't get into the politics of it, but it seemed like there was dependence, right, on not necessarily dependence on this organization, but for a lot of people who lived in the region who worked for the organization, they were more comfortable going there to be safe versus in the local shelter, which they were closer to. And there's like in Family Islands, there's like local governments that actually elections that work in like, how are we going to do things? How are we going to fix things? How are the constituents going to work versus like in Nassau? And I'm not sure how Grand Bahama works, maybe in Grand Bahama too. But like, I don't know if local governments are big there. And like in Nassau, you have your MP, that's who it is. But like local governments and like Luther and all the other Family Islands, you have to go through like different processes through like the local government leader and like making sure X, Y, and Z works. And the issue is, as much as I could talk to the local government leader about, hey, listen, this is going to happen. Now, what are you going to do? And he would look at me and be like, pray. So, like there's a lack of like, again, the disconnect is so there, right? It's so there. And I think that with, hopefully in future work that's being done by the government, like the new DRM and things like that, they'll be working toward like trying to fix those gaps. But like people working on the ground, doing the work on the ground, budgeting for like the local plans and year and what needs to be done. When there is a gap, there's a lot of dependence on these places that come there with this idea of this is how we're going to prepare for it because our interests in our business are key, right? The people who live in the region, that's a secondary concern to the business operations. So that's why, like, and I think sometimes there's like well, I mean, this place is there, so it'll be okay because they're there and they could provide shelter for people who need it if our government shelters don't work, is like a mindset that probably goes through some minds when it comes to it. So there's like I don't want to say slackness, but I would say there's a big disconnect, I think. And once again, I to this day, I was so scared that like they were going to depend on me to tell them like, okay, so listen, like there was a moment in time where like my head of whatever would tell me, you can't tell people this is going to happen because it's going to freak them out. And I was like, but I see it. So I was like scared the entire time. So it was like it was a whole thing. So I'm very much like, yeah, the business versus profit versus people, it all also comes into play with this stuff as well. And that's why I say look at insurance companies if you really want to know what's going on. Look at your insurance rates and everything else to get a good idea of like how serious they are about taking these things. Because insurance companies, a lot of people, I don't know if a lot of people know this, but insurance companies in like larger companies, not necessarily like the insurance companies in the Bahamas. Like I'm not saying Family Guardian can do this, but Family Guardian or like other companies in the Bahamas would have like parent companies, so like in different parts of the US, Europe, and like different places that hire on climate scientists and like weather like folks and statisticians that look at all of these variables and climate models to get an idea of how serious extreme events will be. And from there, they can raise rates and things like that based on it. So a lot of insurance in like home, life, things like that are based on climate science and the modeling I'm talking about right now. So that's why I'm always like, when you check your insurance rates, you get an idea of like, or like you check your contracts, you get an idea of like how serious things are and are about to be. So yeah, the government, I don't really have an answer on like, because I don't know what's going on. I'm not over there, I'm over here, but I have a lot of hope. And I recognize like, I don't like to say put it to people to do the work, but it's also like the reality we live in is like, if you wait on them, you could die. So what do you do?
Yeah, I mean, people do what they need to do all the time. We are constantly doing what we need to do because a system failed.
Yes.
Most people are working, people who are not wealthy are working multiple jobs because it's what they need to do. Is it realistic? Is it right? Is it reasonable? Is it sustainable? Hard no. But they're doing it. It doesn't mean that they should continue to do it. It doesn't mean that the government is exempt and doesn't have to meet its responsibility. And I think we give the government a lie all the time because we figure it out. And we're so used to figuring it out to the point that when you start arguing for things and demanding that the government do certain things, there's a group of people in the same situation as you with not so much privilege to get beyond the issue who will say, well, we can't expect the government to do everything. And it's like, really?
Did you got up.
Did you understand the contract between us and our employees, the government?
Yes, our employees, the government. No, they definitely have to step up. I agree with you on that entirely.
No, I know you're not saying that.
I definitely agree.
But while we say these are the things that we can do within our communities, that we know that we're not supposed to have to do this when there's a government that is taxing us out the ass, taxing us on tax. What's happening with the money? Right? What are you doing to secure us as people? What are you doing beyond securing yourself and the industry that you think is going to like float this country. That's a really funny word to use when we're talking about climate change.
And sea search, sea store search. Sorry.
Yeah, I mean, there's so much work to do, and so much of it falls to us because our government, and I mean every government, successive administrations continue to fail us.
It's
Dorian
just,
happened. And how many proper shelters do we have that were built to be shelters?
I'm telling Alicia, I was scared. I was scared beyond, like, I can't, like, every other day, I'm like, I don't know what's been done since Dorian, for real, guys. Like, I said this in the last one too. I'm not sure how much was actually done to build understanding, to prepare for disasters, to consider how dangerous it really could get. And like, once again, hurricanes, this is the topic, but heat strokes, flooding, weather's getting crazy, it's happening every day. You look at a rain gauge right now, if you're one of the if a school has one, and you will see it for yourself. I don't know. I don't know. I don't know. And this administration is really big on climate change. And
Is it?
I know the finance is what we are. I know we're securing finances and we're pushing the youth forward. And, I love the youth. They're my homegirls. We got a group chat, but I don't know. I'm not sure. I don't know. I think
great, but we can't set them up to be scapegoated.
No. I'm like, those are once again. But I'm just like, uncertainty. Remember the word uncertainty?
Right? These young people are going to change the world. With what? With what money? With what resources?
But what's really funny? Like, I was listening to Whitney Houston today because, again, right? So, I believe the children of the future came out when?
I was just listening to Whitney Houston casually today.
Of course. I always, it always makes me go, so when she's saying the children are the future, I don't think I was a children yet, but I was once one of those youths. I was once one of those children. At what point do we stop passing the torch and somebody just say, okay, so listen, this is what we're going to do. And you build off that. But if we keep on passing it forward, pushing forward, like, this is great, we're going to pass this on to this person. We're going to give this person this awareness. This is wonderful. We're building awareness. And again, the awareness could be better. It could be better. I think the lack of awareness that people have is so jarring to me. It's so concerning to me. I don't know how to, even people who are authorities on the topic, with very few exceptions, concern me. So I'm always like, I don't know how far we're gonna go, guys. I don't know if we fully know what we know and don't know. So yeah. And I will stop there before I say something regrettable.
I was just gonna say, I think we're gonna leave it there. Really positive.
Yeah.
Note. We're gonna let you know again why we're here, why we're doing this, and the link that you need to go to help to make the world a better place. Over to you.
Yes. Please go, it always only takes a spark. Once we said again, tinyurl.org/SUN
tinyurl.com
oh my gosh, this is not good today. tinyurl.com/SUN and that will take you to the Fin Forecast blog with our Sunday donations. I named it that because I just, like the idea of donating things on Sundays. Sunday donations to local GoFundMe pages and international GoFundMe pages for people who are really in need of help and assistance right now. And, you can choose one of them to share every week and focus on promoting it. There's power in sending to WhatsApp groups, sharing with your families, community, churches, all this stuff. Don't forget the power of talking to each other in person when coming to help people with these issues. And, it only takes a spark. We might not have that much power as individuals, but we definitely have a lot of power as community. And yes, that would be the end of my little spiel.
We all
thank
we
you
got.
For joining us.
It's not supposed to be that way, but we all we got.
Internationally, locally, we are all in this together.
tinyurl.com/SUN_DON. Make your contributions, share it with your people. Catch us back here in 2 weeks, again at 6 p.m. Eastern Daylight Time. I think that's about it. Thanks
That
for
wraps
joining
it
me.
up.
And once again, I'm just going to take a moment to look for the button to end the recording. So we're here with you for a few. Here we go. Bye.